Hello, welcome back to a new video in this ModernGX tutorial series. Last video we have stopped there with a circle, and the circle can change its color. Hey, amazing! And what we're gonna do today is we're gonna add a texture to that circle, and exactly that texture here. So we're gonna take this is basically from the thumbnail of ModernGX series, and we're gonna take this 32 bits per pixel BGRA texture, and basically just gonna put this onto the circle, and we're gonna see how to do this with ModernGX. Alright, so we want to add a texture. How do we do that? First of all, let me collapse maybe that class so that we have a bit more space in here. Right, so I already committed the test PNG file, and now we wanna, not committed, but added the file to the project, and now we wanna actually start creating a texture. We need to include, first of all, another type on the GPU, which obviously is the G-type texture, because now, well, we're gonna do a texture. And we need another helper class, which is now actually in the folder coding, and it's for texture coding, for encoding and decoding textures. Currently on this debug release, or not debug, beta release of ModernGX, it can only do decoding, but that's enough for now. But later on in the future it will also support encoding textures so that you can read a buffer back, for example, and store it as an image on your system. So let's use these two classes to get ourselves a texture up and running. So let's go directly after, after that, and do a texture. So first of all, we need to load the texture, or not load the full texture, but get the texture information into CPU space. For that I'm gonna use this coding class, texture file. I'm just gonna call this PNG file, and this PNG file will be located at test.png, and this should work. I could, for example, set a breakpoint here and start the application, and you should see down here in my debug view that our PNG file has some data in it. Especially it has a DirectX format, which is BGRA unome, which is exactly what we got in the Visual Studio debugged window, or not debug but view window. We have the correct resolution 4069, we have 32 bits per pixel, which is also correct, and we have a channel count of 4, which is also correct. So you can already see, just with this one line, we got some meta information about the texture. Now we need to load this texture on the GPU, or better to say, actually specify the GPU object. For that I'm gonna create a new texture, not texture dimension, a new texture. And this texture will be created on our device. It may need the heap allocation cookie or usage. I'm just gonna use the usage because we already have used this the whole video. So I'm gonna use this on the default heap, so it's been resident on the GPU. I'm asking my PNG file for the width. I'm asking my PNG file for the height. We're gonna have a depth of 0, or better to say, actually a depth of 1, because, well, we're just gonna use a two-dimensional texture. Let me also specify, I have forgot that here. Let's also retrieve the DXGI format from the PNG file, which is needing to go in there. And now when we actually name this is our texture. And maybe let's get that down a bit so that you can see this a bit better. So basically this should create ourselves a texture. Let's see if this will gonna work. I'm actually currently always on release, but it shouldn't be a problem. Yeah, so we have a texture 2D with which is a committed resource with a proper pointer. It has its resolutions. I mean, this is all written by me, but yeah, so basically it has some meta information available as well. Now, one thing that is left to do is we need to actually copy the PNG file to the texture, and we're gonna copy this by using, of course, our upload buffer. So now we are asking it to copy a texture and not a buffer. We are copying from the PNG file, or sorry, to the texture from the PNG file, like that. And this should get the texture resident in GPU memory. But we actually gonna have an issue because our texture is quite big. Let's just do the math here. Now we are at kilo mega. You see that for this texture we would need 64 megabytes for uploading, but we just have 16 allocated, so let's just do 128, so that our upload buffer is actually big enough to handle that big texture. Alright, so this should put the texture on the GPU. One more thing I want to actually do, I want to also introduce a resource change to the texture. It's going to get the resource state pixel shader resource, because it's going to be used on the pixel shader. And let's do a resource barrier here, and now the texture should be up and ready for usage. So after these lines we should have the texture available on the GPU. One thing that is missing is the shader, the SRV for the texture. To create this SRV we first need to get a SRV handle range. This is just an allocation on that SRV heap, so we're going to take the descriptor heap and we're going to allocate one descriptor for our texture, and then we're going to tell our texture that it should create a shader resource view on our device for that handle range at position 0, and this should also give us a shader resource view handle. If we execute this, we shouldn't get any issues, but we shouldn't also see something new, because now the texture is up on the GPU, but it has never been used at the GPU. We need to kind of like reference it in the GPU as well, so that we can use it. For that, let's switch to our include file and let's add a descriptor table. And because I don't know that out of my mind, let's open up the Microsoft references here, specifying root signatures in HLSL. Because I always love this document. It's like the most document that I've mostly using for everything. Just kidding, but yeah, I'm using that quite often. So I'm gonna add a descriptor table definition here, just make sure that it is big enough here to handle everything. And instead of that we're gonna have a shader resource view, and let's actually copy that because I'm lazy. Just copy that. We're gonna put this at the texture load 0, and we're gonna have 4 descriptors, and actually we're gonna have some flags. I'm not quite sure if it's called flags or flag. Let's just keep scrolling a bit. It's called flags descriptor volatile, what we are looking for. Why are we using the flags descriptor volatile? Because these descriptors are volatile, which means that they can change and DirectX is not performing too many checking. So by default, as you can see, we are just using this one descriptor that we have allocated. And if we would bound this without the descriptor volatile flag, DirectX would complain about 3 invalid descriptor in our table, in our descriptor heap. And to avoid that issue, or just to avoid that message on the DirectX output, we're going to set the flags to descriptor volatile, which tells DirectX that these descriptors are volatile. They may change, there might be change between draw calls or whatever, and it's just keeping track of what's going on there and checks that everything is correct. Or not checks that everything is correct, how you would like imagine that. So now let's actually add some more documentation. We're gonna have a table here, and this table gonna have some table slots. So we're gonna have an SRV. Let's maybe, yeah, let's just also move this in a bit. So we're gonna have an SRV texture 0, which is our, maybe let's also tag this that we have 4 of them. Move this a bit aside and say these are our textures. Alright, now let's go into the shader itself, the pixel shader especially, and let's define these textures. So we're gonna have texture 2D of type float 4, so 4 channel textures. And these are our textures, and actually we're gonna have 4 of them, even though we're just gonna use 1 of them for now. Now we have access to the texture, but a texture is nothing without a sampler, so we're also gonna create a static sampler, which does not need binding from the CPU side, but of course needs to be in the root signature. This static sampler, we don't need any arguments for now, we just define it at S0, so just a static sampler at S0, which is basically just a default sampler that we can use to sample from the texture. So let's define the sampler. I'm just gonna call this default sampler here, and this is at register S0. And of course we need some semicolons here as well. And basically what this allows us now is to sample from the texture using this default sampler. So the first thing that we were doing was our circle computations. And what we're now gonna do is we're gonna sample from texture, and then we're gonna composite something. Composite. Alright, now sampling from a texture yields a float 4 because it's a 4 color or 4 channel texture. We're just gonna call this texture color, and this will be equal to textures. We're gonna take the first texture, just hardcode the first one here, and we're gonna sample from the texture. And we're gonna sample using default sampler and some two-dimensional coordinates. And to get these two-dimensional texture coordinates, by default you would think something like, yeah, just take the UV coordinates. But actually no, we cannot take them raw, because the problem is that if we would take them raw, they would range from -1 to 1. X coordinate would start at minus, Y coordinate would start at plus. So the first thing that we need to do is we need to invert our Y coordinates so that both of them start at now -1. So kind of like top left is now -1, -1. But we actually want to have as our top left 0 and as our bottom right 1. And now we have as top left -1 and the bottom right 1. Well, -1, -1, 1, 1. And to fix that issue, we're gonna add 1 floating point to that, from unit of floating point. Now we have the top left at 0 and the bottom right at 2. And then, after the addition, important math, you need to check the math here for the brackets. Now, after that, we're gonna divide this by half, which basically means, well, if we are at 0, it stays 0, so top left still 0, and bottom right, which was 2 previously, divided by half is 1, and of course it linearly interpolates between of them as well. So this, I don't know why this is so fucked here, but yeah, this IntelliSense here. Microsoft never really managed to do proper IntelliSense for HLSL. I don't know why, but yeah, they can't. I don't know why. So yeah, so basically this should give us the right texture coordinates that we need for sampling from our texture. And what we're now gonna do, we're actually gonna replace our old color with the texture color, and we multiply this by the distance, of course, for the circle, and we add one floating point, and of course one floating point unit for the alpha values, because it's solid geometry that we are drawing. Alright, now we need to make sure this works from the other sides as well. If I would start this now, it's not gonna work. Why is it not working? Because it's a float 4 and we are compositing a float 4 out of a float 3 and the single float. So we need to type RGB here as well, and now this should compile and you should get nothing. We didn't get a device removed, is good, but at least on debug we should get some debug layer messages. So let's see. Give us some messages, little debug layer, and it didn't give us messages. Yeah, I know why it didn't give us messages. It didn't give us messages because the descriptors are volatile, so it didn't do some checkings on them. Well, obviously. Yeah, but now let's actually do everything that we need in the C++ code as well. Because we had another root signature element, we need to of course define this as well. So we want to define the new root configuration entry. We want to do a descriptor table, and this descriptor table will be started at the, how did I call this? SRV handler range 0. So it will start at the same. Do you have an issue with that? Of course, we want to make descriptor table, not descriptor table itself. So just like that. And this is now referencing our descriptor table, and this should be bound. But we're gonna have an issue. We're gonna show you in a second. As soon as we're gonna start, we get a device removed error, and we get a DirectX error, C graphic comment list, blah 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 blah. No CBV SRE UAV descriptor heap is currently set on the comment list. So setting a root descriptor table handle is invalid. So we are not allowed to basically set a table when no heap is bound. DirectX only allows one sampler and one CBV RTV, not CBV RTV, CBV SRV UAV table. So basically we are just allowed to use, inside of our root signature in one of our draw codes, we are only allowed to use samplers and constant buffer view descriptors or shader resource view descriptors or unordered access view descriptors from one, or better to say 2 single heaps. We just have 2 of them. One for CBV, SRV, UAV and one for samplers. And because we are just allowed to use one, we need to bind it, and changing between them is actually expensive. So we want to actually bind this here before we bind our pipeline state and our root signature. Or actually we could bind the pipeline state and then bind our heaps. This is basically a call to the command list. We can say set heaps. Basically, actually this should be called set descriptor heaps, this function. It may change in the future. This is why we are on debug, so that I can change stuff like this. So yeah, I'm just gonna import shader resource view descriptor heap. It should also be, yeah, okay, it's an okay, it's taking DirectX heaps, so this is good. So I'm just gonna set descriptor heaps, call this function here, just with a SRV descriptor heap. And if I now start this, I don't know if you should already see a texture. Yeah, we already see a texture. I wasn't quite sure if we had everything lined up, but this is how easy ModernGX is. There is our texture, everything is looking good. If I would reference that side by side, let me open up the PNG quite quickly. You can see that all the bounds are correctly like this shape, which is kind of like from the right to the left bottom. It's also here from the right to the left bottom. Our colors look correct, and of course we still have our nice circle that can be resized and has some nice anti-aliasing. So yeah, there you go. This is how easy you use ModernGX. And well, that video actually concludes the ModernGX tutorial series, and now we can continue on with real-time rendering. So yeah, thank you for watching. We're gonna see us in the future, maybe also in the future with a new ModernGX video, in case I may update and bring out a new beta version of ModernGX, and I probably also do you a quick update video where I tell you what's new and what you need to change basically on the side of the tutorial. So we're gonna live upgrade in the tutorial to the new ModernGX version, and I'm gonna show you how we're gonna change stuff that things are working, of course. So yeah, thank you for watching, have a nice day, see you in the next video, make sure to like and subscribe, and yeah, bye!